All right, let's just dive right in. Welcome to this explainer. Today, we are completely ditching the static presentations and stepping straight onto the factory floor. We're going to go through a really action-oriented technical overview of how Google Cloud takes the absolute chaos of machine vibrations and transforms it into automated revenue protection. Seriously, we're talking about stopping revenue bleeding downtime dead in its tracks using GCP's Manufacturing Data Engine and Vertex AI. If you're in heavy production, automotive, or honestly any industry relying on continuous mechanical operation, you already know exactly how critical this is. So let's get right to the data. Millions, literally millions of dollars. Every single minute that an industrial motor or a complex bearing assembly goes down in a heavy production environment, these industries are bleeding revenue to the tune of millions annually. It is a massive, incredibly frustrating drain on resources. And we aren't just talking about a minor glitch where someone walks over and hits a reset button. We are talking about entire production lines grinding to a devastating halt, missing delivery targets and hemorrhaging capital, while crews are just scrambling to figure out what went wrong. Just picture this, an extreme close-up of a massive, high-vibration industrial motor right on the verge of total failure. Imagine looking at it through a digital lens, where you've got live sensors urgently flashing green and yellow telemetry data straight from the plant floor. It's raw, it's chaotic, and it is moving incredibly fast. Now, in a traditional setup, all of this frantic data, it's usually siloed, ignored, or it's simply moving way too fast for human operators to interpret before a physical piece of metal actually snaps. We have to capture that live flashing data and do something meaningful with it before disaster strikes. So, how do we actually pull that off? Let's get into Section 1, Streaming Telemetry to the Cloud. The whole journey for this critical physical data starts right at the Manufacturing Connect Edge, or MCE. You can kind of think of MCE as the highly intelligent bouncer at the door of your factory. It sits right at the edge layer and actively grabs those raw, chaotic vibration metrics, the temperature readings, the current consumption streams. Then it translates all of this incredibly complex operational technology data using standard OPC UA protocols. Because without this bridge, your machines are essentially speaking a language the cloud just doesn't understand. MCE translates that high-frequency mechanical stress into a perfectly clean digital stream, ready for transport. And the sheer velocity of what happens next is honestly staggering. We're talking telemetry continuously streaming at a blistering 100 hertz. That is 100 data points per second per sensor, flowing instantly from the edge right into Google Cloud Pub Sub and Cloud Dataflow. But, raw data isn't enough on its own. It then hits the Manufacturing Data Engine, MDE, where it is instantly structured, contextualized, and pushed directly into BigQuery in real time. We are not just dumping numbers into a data lake here. We're creating a live, highly organized digital twin of the factory floor's physical reality that's ready for immediate analysis. All right, so now that we have all this structured, high-frequency data living in BigQuery, what's next? Section 2, Vertex AI Anomaly Detection. This is absolutely crucial because it's all about the profound difference between reacting and predicting. Think about traditional threshold alerts, the systems most factories still rely on today. They only scream for help right as the physical damage actually occurs. By the time that red light flashes, the bearing is shredded, the motor has seized, and you're already losing thousands of dollars a minute. But then you look at Vertex AI forecast and custom anomaly detection models. By continuously analyzing that 100 hertz data, Vertex AI spots microscopic invisible microfrequency anomalies up to 3 weeks prior to total mechanical lockup. 3 weeks. That is a massive operational superpower. Imagine having a clean, live Vertex AI dashboard right in front of you. No static bullet points, just live time series anomaly detection models that have been rigorously trained on your deep historical BigQuery datasets. You'd see the precise degradation curve of a specific bearing over time. You are literally watching a future failure slowly materialize on your screen, weeks before anyone on the factory floor could ever hear or feel a vibration. It changes the entire paradigm from blind panic to calm, calculated foresight. But let's be real, predicting a failure without actually acting on it is just a really sophisticated way of watching yourself lose money. That leads us to Section 3, Automated Closed-Loop Maintenance. The true magic here is the orchestration. When Vertex AI detects that a bearing is going to fail in 3 weeks, no one has to pick up a phone. Instead, GCP Pub Sub catches the anomaly flag and instantly triggers a fully automated closed-loop system. It talks directly to your enterprise systems to instantly generate an automated SAP work order. It triggers a zero-touch ordering process for the exact replacement parts you need, and it schedules the maintenance team to do the repair during already planned idle hours. The entire logistics process is handled completely automatically by the cloud ecosystem. 85%. That is the ultimate payoff of this entire architecture. A technician casually walks up to the machine with the right part, right on time, and replaces that dangerously worn bearing before the motor ever actually breaks. Because of this end-to-end flow, from edge sensors to BigQuery to Vertex AI directly into SAP, unplanned plant downtime is reduced by up to 85%. You aren't just saving a motor, you are fundamentally protecting the revenue stream of the entire facility. So, as we wrap up this explainer, I want to leave you with one absolutely critical question. What is the exact latency between a machine in your facility beginning to fail and your system actually noticing? Are you still waiting for the physical snap of metal, operating purely on reactive alerts? Or are you capturing that high-frequency data to predict the future weeks in advance? Because as we've seen today in heavy industry, every single minute of latency between a mechanical anomaly and system awareness is revenue lost forever. The tools to close that gap entirely exist right now in Google Cloud. The rest is up to you.